Yes, in this video I am going to revise differentiation from Edexcel International A-Level P4, Pure Mathematics 4 subject. In P4, in Pure Mathematics 4, we have two differentiation cases. One of them is implicit differentiation, where we have x and y together, and remember derivative of y is dy over dx, so derivative of y to the power of n is ny n minus 1 times dy over dx. If you differentiate anything with y, you have to put dy over dx there, such as derivative of y squared is 2y dy over dx, or derivative of e to the power of y is equal to e to the power of y dy over dx. You know derivative of e to the power of y is e to the power of y itself times dy over dx, or derivative of ln y is equal to, what is derivative of ln x? It is 1 over x. So this is going to be 1 over x dy over, sorry, dy 1 over y dy over dx. So let's do an example using, and before that, let me remind you that to be able to find the gradient of tangent line for any curve of tangent, we have to take dy over dx and substitute x value or t value or y value in m tangent in dy over dx. And we have to remember that m tangent times m normal is always equal to minus 1 because they are perpendicular to each other. Let's solve question 1. X to the power of 4 plus 3xy minus x minus y cubed plus 9 is equal to 0. To be able to find dy over dx, let's first step is to find dy over dx. Is equal to 0. Take the derivative. What is derivative of x to the power of 4? It is 4x cubed. We have a product here, so we are going to apply the product rule. The first equation is 3x, the other one is y. So derivative of 3x is 3, derivative times the second one, times the derivative of second one, which is y, and its derivative is dy over dx, times the first expression 3x, minus derivative of x is 1. What is derivative of y cubed? It is 3y squared dy over dx. You have to remember that when we take derivative of y, something in terms of y, we have to put dy over dx at the end of this statement. And derivative of 9 is 0, derivative 0 is 0. So take dy over dx outside of the brackets. In the brackets we are going to have 3x and minus 3y squared, and move these three expressions to the left hand side. 4x cubed is going to minus 4x cubed minus 3y plus 1. So dy over dx is equal to minus 4x cubed minus 3y plus 1 divided by 3x minus 3y squared. And to be able to find the tangent in dy over dx, we have to substitute x is equal to, that's the answer for part B. Find equation of tangent at y minus 1 and 2. X is equal to minus 1, y is equal to 2. So m tangent is going to be minus 4 minus 1 cubed minus 3 times 2 plus 1 divided by 3 times minus 1 minus 3 times 2 squared. So m tangent is equal to 4 minus 6 plus 1 over minus 3 minus 12. So m tangent is equal to 1 over 15. And the equation of the tangent line is m tangent x plus c and passes through the point minus 1, 2. Y is equal to, let's substitute the value of m tangent in the equation there, 1 over 15 x plus c. Substitute the given x value and y value there. 2 is equal to 1 over 15 minus 1 plus c. C is equal to 31 over 15. So y is equal to 1 over 15x plus 31 over 15. And this is the solution of example 1. That's the solution of example 1. Now check the revision and the question that I solved for you, and I will carry on with question 2, and that is a parametric question. We are going to use parametric differentiation for that question. Yes, let's carry on with question 2, but before that, let me remind you the differentiation about implicit equations. Parametric equations is when x is in terms of t and y is also in terms of t. And if we want to differentiate, first of all we have to differentiate y with respect to t and also find derivative of x with respect to t. And again, to be able to find the gradient of the tangent, we have to find dy over dx and substitute t value there. And if you want to find the gradient of the normal line, we have to remember that m tangent times m normal is equal to minus 1. So let's carry on with question 2. And in question 2, as you see, our parametric equations are using trigonometric formations there. So for question 2, x is equal to root 2 sine 2t, y is equal to 2 sine square t, and we have to remember the derivatives of trigonometric functions. Also, we have to remember the trigonometric identities to simplify the expressions that are in terms of trigonometric functions. First of all, let's find dx over dt. Sine 2t is there. And the derivative of sine is cos. Root 2 sine 2t, and the derivative is going to be 2 root 2 cosine 2t. And let's find the derivative of dy over dt. We have square there, so it is going to be 2 times 2, 4 sine t, and derivative of sine, which is cos t. Now we know that dy over dx is equal to dy over dt over dx over dt. What is dy over dt? Already found there. 4 sine t cos t over dx over dt, which is 2 root 2 cos 2t. Now, as you see, we already found the derivative of dy over dx in terms of trigonometric functions, but when you check the answer there, it's not in the form that we want. So we have to use trigonometric identities here to obtain an answer in the form of k times tangent 2t. Now, as you see, we have here 2 times 2 sine t cos t, where we have to remember that 2 sine t cos t is equal to what? Sine 2t. We have to remember the trigonometric identities also, over 2 root 2 cos 2t. And in place of 2 sine t cos t, I am going to put 2 sine 2t over 2 root 2 cos 2t. And sine 2t over cos 2t is tangent 2t. Sine 2's cancel each other. So this is 1 over root 2 tangent 2t. And in place of that, we can write root 2 over 2, the rationalized form of 1 over root 2 tangent 2t. And that is dy over dx, and it is in the form of the answer that is asked in the question. That's the answer for part A. For part B, tangent is dy over dx when t is equal to what? Pi over 3. So tangent is going to be root 2 over 2 tangent 2 times pi over 3. And by the help of our calculator, let's use the calculator and to find the value of it is minus root 3. So tangent is equal to minus root 6 to root 2 times root 3 is root 6 over 2. So y is the equation of tangent is equal to tangent times x plus c. And we don't know the corresponding point when t is equal to pi over 3. So let's find x when t is equal to pi over 3. X is equal to root 2 sine 2 times pi over 3. X is equal to root 2 root 3 over 2. So x is equal to root 6 over 2. And when t is equal to pi over 3, y is equal to 2 sine squared pi over 3. Y is equal to 2 times root 3 over 2 squared. Y is equal to 3 over 2. So y is equal to, and in place of tangent I am going to substitute minus root 6 over 2 x plus c, and passes through the point root 6 over 2, 3 over 2. 3 over 2 is equal to root 6 over 2 over 2 times root 6 over 2 plus 6, sorry, 3 over 2 minus is equal to minus 3 over 2 plus 6. So c is equal to 3. Y becomes minus root 2 over minus root 6 over 2 x plus 3. Yes, that's the answer for example 2 there. And that's an example for parametric differentiation. And we will carry on with rate of change question. question 3. Now, the third topic under differentiation revision is going to be rate of change. When you see a rate of change question, we have to remember that either dv over dt is equal to dv over dr over dt. Here v is the volume, or dA over dt is equal to dA over dr over dt. Here I use r for radius, but that variable may change. Instead of r, we may, here a is the area, but instead of r, we may have x, the length, or the height, h. That is the case in question 3. Here we have a cone. We are going to use a little bit geometry and a little bit trigonometry here, but they are in the level of IGCSE, so it is going to be easy to calculate. Say this is the height, that's the radius, and height and radius is perpendicular to each other. If this is 120 degrees, so that angle is going to be 60 degrees. So tangent 60 is equal to r over h, and we know r in terms of h for this question. So r is equal to root 3h. Now, what is the volume of a cone? Volume of a cone is 1 over 3 pi r squared h. In place of r, I am going to substitute its equivalent, which is found in terms of h, because we want the volume in terms of h only. 1 over 3 pi root 3h squared times h. Volume is 1 over 3 pi 3h squared times h. 3's cancel each other. Volume is equal to pi h cubed, therefore shown. With the help of trigonometry and geometry, we found v, the volume in terms of h only. Now, because we have volume in the question, and it is rate of change, we have to remember that dv over dt is equal to dv over dh times dh over dt. And here the variable is h instead of r. And we know that volume is pi h cubed, so dv over dh is equal to 3 pi h squared. Then dv over dt becomes 3 pi h squared times dh over dt. Let's read the question. And the volume changes. dv over dt is minus 1 over 1.8 centimeter cube per second for this question. The leaks out means the volume, we are losing from the volume, means we are losing from the volume. And let's substitute that. 1 minus 1 over h, 3 pi h squared dh over dt. So minus 1.8, 3 pi h squared is equal to dh over dt, and that's lambda is the constant there. Lambda is minus 1.83 pi, which is minus 0.6 over pi. So dH over dt becomes minus 0.6 pi 1.1 over h squared. That's dH over dt in terms of h. That's the end of the video. These are the three examples about differentiation in P4, that is a unit in Edexcel International A-Level. So, see you. Bye. Finished.